Assalamualaikum and hi everyone. I will continue chapter 9, differentiation, lecture 3 of 5, part 2. Okay, we will continue with the derivative of a logarithmic functions. So the natural logarithmic function is differentiable for all x more than 0. So recall back, what is the natural logarithmic functions? The natural logarithmic function is any function to the base e, that is ln x, log base e. So if you are given a function y equals to ln x, okay, so what is dy dx? Dy dx is equals to 1 over x, or you have to memorize this formula. Okay, so how to prove? If given y equals to ln x, we change from log form to exponential form, ey equals to x. Then differentiate both sides with respect to x. So now differentiate, or d dx, differentiate ey is an implicit differentiation because we want to differentiate y, a function in terms of y, with respect to x. So the answer is ey, and differentiate y itself, differentiate y is dy dx. So you must follow by dy dx. So that's why I get this one. Differentiate x, the answer is 1. So we get dy dx equals to 1 over ey. Therefore, d dx ln x equals to ey. What is ey? X. What is ey? X. So the answer is differentiate ln x is equals to 1 over x. You have to memorize the formula. Okay. The log is only taken for the base e or ln x. Okay, now we continue to the natural logarithmic function of the form y equals to ln fx, where fx is a linear function of x, or you can write simply as fx equals to ax plus b, linear function. Okay, so what is the derivative of ln fx? So take a look at the proof here. If given y equals to ln fx, by using chain rule, you let fx as a u equals to fx. So what is y in terms of u? Y equals to ln u. So differentiate u, we get du dx, or f prime x. If y equals to ln x, so the answer is here. So y prime equals to 1 over dy du over 1 over u. So by using chain rule, we substitute the derivative dy du equals to 1 over u, du dx equals to this one, f prime. So the answer is fx over x. Okay, so d dx f prime x is equals to 1 over fx multiply with f prime x. Okay, or simply you write in a form of this. Differentiate ln x is equals to f prime x over fx. Okay, I write one more time. D dx ln fx is equals to 1 over fx, and don't forget to differentiate fx. Differentiate fx, the answer is f prime x. Okay, so what is fx? Fx is a linear function, that is ax plus b, a linear function. Okay, I hope you memorize this formula because we will use after this. A, y equals to ln 3x. So y prime equals to 1 over 3x. Then you need to differentiate 3x. d dx 3x. Differentiate 3x. So the answer is 1 over 3x. Differentiate 3x. The answer is 3. So 3 is cancelled out. So the answer is 1 over x. Okay. Please memorize the formula, yeah. d dx, one more time at right here, ln ax plus b. The answer is 1 over ax plus b. Then differentiate a plus b, the answer is a. The answer is a. So take a look at example b. Y equals to half of ln 5 minus 3x. So dy dx equals to, actually we will use product rule here. So 1 over 2 is u, ln 5 minus 3x is v. Okay, by using product rule, u v prime, what is u? 1 over 2. Differentiate ln is 1 over 5 minus 3x. We haven't finished yet. You have to differentiate inside the ln 5 minus 3x. Then you right here differentiate 5 minus 3x plus differentiate ln 5 minus 3x. Then differentiate 1 over 2. Differentiate 1 over 2, 0. So actually you don't have to write this. So the answer is differentiate 5 minus 3x, negative 3. So negative 3 over 2 times 5 minus 3x. So this is the final answer. Okay, C. Given y equals to x ln x. We will use this by using product rule again, or by let u equals to x and v equals to ln x. Differentiate u prime, or du dx. Differentiate x, 1. Okay, differentiate v prime, differentiate ln x. We have learned just now, 1 over x. So dy dx is equals to u v prime, x multiplied with 1 over x, plus v u prime ln x multiplied with 1. So the answer is 1 plus ln x. Okay, what about d? Y equals to ln x over x. Okay, so u is ln x, u prime or du dx equals to 1 over x. Then we have v equals to ex, v prime equals to ex also. Substitute into the formula by using quotient rule. This one we use quotient rule. vu prime ex multiplied with 1 over x minus uv prime ln x multiplied with ex over v squared ex squared. So the answer is ex over x minus ex followed by ln x over ex squared, or you can write as e to the power of 2x. Okay, then you simplify to get factorize e dy dx, factorize ex. So in the bracket we have 1 over x minus ln x over e to the power of 2x. Okay, so now we move to the next differentiation, that is differentiation of a trigonometric functions. So the 6 trigonometric functions here are sin x, cos x, tangent x, secant x, cotangent x, and cosecant x. So we will differentiate each term here. You have to memorize this formula. Okay, so differentiate sin x equals to cos x. Differentiate cos x equals to negative sin x. Differentiate tangent x equals to secant squared x. Differentiate cotangent x equals to negative of cosecant squared x. Differentiate secant x equals to secant x tangent x. Okay, see the rhythm here, secant x tangent x. Differentiate cosecant x equals to negative cosecant x cotangent x. Okay, so please take note that this formula are only true for the angle which are measured in the unit of radian. So x here is in unit of radian. Okay, I hope you please memorize the formula. Okay, now take a look at example 5. Differentiate with respect to x. d dx differentiate to sin x minus 3 cos x. So the answer is, I will use product rule here. To differentiate sine, the answer is cos x. Then plus sin x. Differentiate 2 is 0, so you don't have to write actually. Minus 3, differentiate cos is negative sin x. Okay, so this one is actually 0, you don't have to write after this. Yeah, so the answer is 2 cos x plus plus 3 sin x. Okay, now we move to the second part, is B. Differentiate 4 tangent x minus 5 over x. Okay, for 5 over x here, you can write as 5x to the power of negative 1. Okay, so differentiate 4 tangent x minus 5x to the power of negative 1. So the answer is 4. Differentiate tangent, the answer is secant squared x. Okay, don't forget squared. Squared x minus 5. Differentiate x to the power of negative 1, you have to bring negative in front. X to the power of negative 1 minus 1, negative 2. Okay, so the answer is 4 secant squared x plus 5 over x squared. So this is the final answer. What about C? Okay, for C, I would like to write in another form. I will let y equals to 4 cosecant x plus 3 cotangent x. So dy dx is 4. Differentiate cosecant x, we get negative cosecant x cotangent x. Okay, plus 3. Differentiate cotangent x, the answer is negative cosecant squared x. So now we will factorize. Both term we have negative in front. Both term we have secant. So cosecant. So cosecant x in bracket. So the remaining is we have 4 cotangent x. Then plus 3 cosecant x. Okay, so this is the final answer. Okay, now I will continue with the derivative of a trigonometric functions where the function is sin u. Okay, so what is u actually? U is any function in terms of x. So what is u? U is any function in terms of x. So just now we just differentiate sine x. The answer is differentiate sine x. The answer is cos x. Now we want to differentiate sine u. What is u? U is any function in terms of x. So when you differentiate, you have, for example, a differentiate sine u. The answer is cos u. Then you need to differentiate u. Differentiate u du dx. Okay. Okay, take a look at b. D dx cos u. Differentiate cos u. The answer is negative sine u. Negative sine u. But we haven't finished yet. You have to differentiate u. So differentiate u d dx u. Or you can write as u prime. Okay. C. Differentiate tangent x. The answer is secant square. Differentiate tangent u. The answer is secant squared u. Then differentiate u. The same method we apply for cotangent, secant and cosecant. Differentiate cotangent like the previous formula. The answer is negative cosecant squared x. Then you need to differentiate u. Differentiate u d dx u. Okay, so differentiate secant u. The answer is secant u tangent u. Then differentiate u. Okay, the last one, differentiate secant u. Okay, this is u here. Differentiate secant u. The answer is negative cosecant u cotangent u. Then you have to differentiate u with respect to x. Okay, I hope you understand the formula. Take a look at the next example. Find the derivative of cos 5x plus 4. So you have to differentiate cos 5x plus 4. So the answer is differentiate cos is sine. We have negative in front. Negative sine of u. So what is u here? 5x plus 4 is a u here. So you substitute. What is u? 5x plus 4. Then we haven't finished yet. You have to differentiate u. Okay, so d dx is the operator, means you want to differentiate. What is u? Substitute. What is u? 5x plus 4. Okay, follow or not? So the answer is negative sine 5x plus 4. Differentiate 5 plus 4. We have 5. So normally we will bring the constant in front. 5 will be in front with negative 5, then followed by sine 5x plus 4. Okay, this is the simplest form. Okay, now B. Differentiate sine ln x. So the answer is differentiate sine. The answer is cos u. So ln x here is a u. U equals to ln x. Okay, so cos u, what is u? Bracket ln x. Then you haven't finished yet. You have to differentiate u. What is u? Ln x. So the answer is cos bracket ln x. Differentiate ln. We have learned before. Differentiate ln is 1 over x. So final answer is cos ln x over x. Okay. Now we move to C. Differentiate tangent pi over 6 minus 3x. Close the bracket. So what is the answer? When you differentiate tangent, the answer is secant squared. So the answer is secant squared. Secant squared u. What is u? Just copy paste u. Pi over 6 minus 3x. Okay, remember you haven't finished yet. You have to differentiate u. the inner part here. So differentiate pi over 6 minus 3x. So the answer is secant squared pi over 6 minus 3x. Differentiate pi over 6 is 0. Differentiate negative 3x, negative 3. So the answer is negative 3. Okay, because this one is 0. So as usual, you have to bring negative 3 in front. So negative 3 secant squared pi over 6 minus 3x is the final answer. Okay, last one. Differentiate differentiate d dx, differentiate secant 2x plus 3. So what is the answer? The answer is differentiate secant. The answer is secant tangent. So the answer is secant 2x plus 3 and followed by tangent 2x plus 3. Then you have to differentiate u. What is u? 2x plus 3. Okay, so the answer is, okay, now differentiate 2x plus 3. The answer is 2. Now I will bring 2 in front. 2 secant 2x plus 3 multiply with tangent 2x plus 3. Okay, so this is the last, this is the solution, the simplest form. Okay, now we continue to the last part of a derivative of a trigonometric functions. The function that we are going to differentiate now is in the form of sine x to the power of n, or sine u to the power of n. So for example, we want to differentiate d dx, differentiate sine u to the power n. Okay, so please take note, what is u? U is any function in terms of x. What is n? N is power. N is power. So what is the answer? Actually, in trigonometry, when you write sine u to the power of n is actually equals to sine u, the whole thing here is power of n. Okay, but we always write in this form. Okay, we usually write in this form that I tick here. Okay, actually these two are equal, so we can use general power rule here because n here is power. So by using power rule, what you can do is, n is power, you can bring n in front, then you copy sine u, but don't forget the power for sine, you must minus 1. Okay, then you haven't finished yet, you have to differentiate sine x, sine x without the power n, yeah, differentiate sine u, differentiate sine u, the answer is cos u. Then we differentiate the inner part here, differentiate u, so you have to differentiate u here. Okay, this is how I managed to get A. Okay, we use general power rule, n is the power. Okay, now take a look at B. Differentiate cos u to the power of n. So similar like A, you have to bring n in front, then differentiate cos u, the answer is sine, bring n in front, then you copy cos u to the power of n minus 1, then you have to differentiate cos u. without n, yeah, differentiate cos u, the answer is sin u. Then you differentiate u. Differentiate u, du dx. Okay, I hope you understand. Now see, differentiate tangent u to the power of n. So the answer is n tangent u to the power of n minus 1. Okay, then differentiate tangent u. The answer is secant squared u. Then differentiate u du dx. Okay, so if you understand these three basic rule, now for the next three, it will be easier. So same like sine, cos and tangent. Now differentiate secant squared u. So the answer is n secant n minus 1 u. Then differentiate secant u, tangent u, then differentiate u. Okay. D, differentiate cotangent u to the power of n. The answer is negative cotangent n minus 1 u. Then differentiate cotangent u. The answer is cos negative here, negative cosecant squared u. Then differentiate u. And for the last one, differentiate cosecant u to the power of n. So the answer is n cosecant n minus 1 u. Then differentiate cosecant u. The answer is negative cosecant u, cotangent u. That's why we have negative here. Then differentiate u. So this is the last formula that you have to memorize. We can differentiate actually by using general power rule because n here is power. Okay, take a look at the example. Differentiate y equals to secant squared 2x. So dy dx is equals to, so we have power here 2, so you have to bring 2 in front. 2 secant 2 minus 1 is 1, so you don't have to write 2x. Then you have to differentiate secant 2x. Okay, without 2, yeah, secant 2x only, this one. Secant 2x. So the answer is 2 secant 2x. Differentiate secant. The answer is secant x tangent x, right? So now the answer is secant 2x tangent 2x. We haven't finished yet. You have to differentiate 2x. Okay, so right here, differentiate 2x. So the answer is, differentiate 2x, the answer is 2. So I will bring in front. 2 times 2, 4. 4 secant 2x. And we have secant, another secant 2x, tangent 2x. So we conclude here, the answer is 4 secant squared 2x because we have 2 secant 2x here, tangent 2x. Okay, that one is A. What about B? Y equals to cosecant x to the power of 4. So dy dx equals to 4 is power here, so bring in front cosecant 4 minus 1, don't forget to subtract by 1, so 3x. We haven't finished yet. You have to differentiate cosecant x. Okay, so the answer is 4 cosecant x to the power of 3. Differentiate cosecant, the answer is negative cosecant x cotangent x. Okay, so lastly, this one cotangent. So lastly, the answer is, I will bring negative in front, so negative 4 we have 2 cosecant here, so we combine. So we have negative 4 cosecant to the power of 4x cotangent x. This is the last one. Now the final answer. Okay. Okay, now we continue B. Y equals to sine x squared plus 1 to the power of 3. So differentiate y dy dx. Then you have to bring 3 in front. 3 sine 3 minus 1, 2. Then what is u? Just copy and paste. X squared plus 1. Then you need to differentiate. Which term? Differentiate sine x squared plus 1. Okay, don't include 3 here, no? Only sine x squared plus 1. So the answer is 3 sine squared x squared plus 1. Differentiate sine, the answer is cos x squared plus 1. Then you need to differentiate the inner one, that is u. What is u? X squared plus 1. So the answer is 2x. Okay, for this one the answer is 2x. Okay, I will bring the answer in front. So the 2x multiply with 3 sine squared x squared plus 1 multiply with cos x squared plus 1. So the answer is 2 times 3, 6. 6x sine squared x squared plus 1 cos x squared plus 1. Okay. What about D? If y equals to cotangent squared 3x. Okay, so what is the answer? dy dx is given by 2. Okay, we have power here 2. Then cotangent 3x. 2 minus 1 is 1. You don't have to write 3x. Multiply with derivative of cotangent 3x. So 2 cotangent 3x. Differentiate cotangent, the answer is negative cosecant squared. So negative cosecant squared 3x. Just follow the when the u is 3x, so here also 3x. So make sure we haven't finished yet, right? So you have to differentiate 3x. So d dx 3x. So the answer is 2 cotangent 3x. Negative of bring in front, cosecant squared 3x. Differentiate 3x, the answer is 3. So we will combine 2 and 3. So the answer is negative 6 cotangent 3x. Cosecant squared, we have squared here. Cosecant squared 3x. Okay, I hope you understand how to use the formula in derivative of a trigonometric ratio. We have 6 formula to be memorized. Thank you.